Yes. Jeg må egentlig være med. Det var veldig raskt. Vi fikk jo absolutt ikke av det.
Absolutt dagen trengte.
Yes, korrekt. Men det var forestillende middagsskolen. Ja. Det var etter minnekontoret, så andre ting jeg kan bruke det.
Hey, I had a question about the Go Getting Started file.
Yeah.
What do you need to insert into the proc file to launch it?
Go Getting Started. Help me here. You're doing the Go tutorial, right? So, hang on. Is that okay? Will it work? What's the course code again for this course here?
Sorry?
What's the course code again for this course? Do you remember?
IMT2681.
81. Cool. Thank you. Cool. I follow you, and we have a look.
Jeg har ikke lært. Etterpå da så ble jeg løpt.
Datamaskinen til Trondheim gikk da oppå kassaaparaten. Fordi da kunne du skrive om det, så var det med forsikring, garanti og sånn. Hvor jækla tung var den katten? Jeg ser 10 centimeter fall. Kassa vår. Jeg har aldri hatt dyr hjemme, ever. Jeg mente det var en dårlig unnskyld. Nei, men det var verkstedet som sa det. Bare skriv dette på en garanti og alt er gratis. Jeg skjønte jo det, men likevel. Det er uansett. Ja, nei, men jeg tenkte på beinet.
Men likevel, det er jo fortsatt noen måneder alle 10 000. Ja, altså, selv om jeg klarer å hacke meg til gratis, så synes jeg det er fortsatt, ja. Da, det er egentlig det jeg husker på plassen, så det er i veggen der. Kan du ikke prøve den andre? Kjøpt den etter. Da er nesten sånn, da må jeg ha en ok, da er det bort hos deg.
Men jeg tenkte du også til brukerne med det.
Ja, men ja, for jeg fikk jo noen smart som har 3 brukere. Som jeg ikke har sånn.
Hvis du holder skiften,
Ja, ok.
så går du inn på...
Ja, det var da han sa jeg skulle teste fag. Han sa det til ja, du kan installere, men jeg har egentlig lyst til at du skal finne ut av det. Som en write of message, da. Som
Mario.
Ja.
Det høres som veldig typisk Mario.
Han sa ikke hack, han sa figure out. Men du vet, man kan jo ikke si at det er ikke politisk korrekt når han sier. Anyways, nå er jeg her i grunnen, og så er det. Nå tok jeg skift. Nei, sorry. Men ja, jeg gikk inn på recovery mode. Ja, ok. Give root. Ja, så root jeg allerede har passord. Så jeg får ikke lov til å det var den stilen den ene brukeren hadde ikke passord for det, men de har passord ja, for da, hvis jeg går
Yeah, this one will work. It's a whole
det her er egentlig delen av testen. Nei, i dag skal det lenger så
synes jeg var for dømmende.
ja, det er greit.
But once forgot something.
For at her er det de andre optionene jeg satt da. At når du er her, så fikk du E, så kommer du inn i sånn konflikt. Og så skal jeg liksom edite på slutten her. Jeg skal skrive et annet inn.
Jeg holder på med jeg skal hacke plassen.
Men selvfølgelig
Vi skal inn i alternative root cell. Så man låner en datamaskin, og det bare skjer at han har lov til å bare veie og reinstallere.
Eller, det skuffer seg gjerne. Det er den enkle veien. Han har liksom gjort det veldig klart. Det kan bli skuffet.
Ja, den alternativet. Gå opp til der du valgte så nå prøver vi han og alternativt skjell som kan åpne med hjelp av litt vikling. Nå prøver han prøver å utfordre
Nei, da prøvde jeg først.
Du er der, sant?
Det var første eksamen jeg var ganske flest. Og bare gå inn i Zoom og skrive. Prøve password. Prøve altså, prøve litt sånn kjærpass. Ja, kan du liksom gine litt mer. Så her. White flash.
Du skal ha en lang kernel etter å klikke E. Du klikker E på generere. Har du det som heter kernel? Hva gjør du med kernel? Så er det ikke så du har det. Det er bare veldig hvis jeg vet hva du kan bli. Ja, men så har den også på en som
All right. So, I noticed, hey guys, I think we should start, else we won't be able to finish on time. We won't anyway. Hey people in the far corner, thank you. Cool. Sweet. So, I noticed there seems to be usually a box of cables available in that room, right? A255, I heard this from some guys over there. Does anyone know about this, or is it, was it the case in the past? Because I literally don't know about it. I'll find out after the lecture, because it's, I think, the preferable approach to really have network cables to plug in your machines. Otherwise, the network connectivity is a bit too flaky, especially if you want to push rather large files over the network, right? So I'll figure that out, but I ideally use cables if you can. Next question, how far are you guys? I know some people recovered their laptops from interesting experiences, but that shows you the importance of backups, right? Did you have backups? Okay, most of it. Okay, good. So that's the first slide I will make for the next time I run that course. How far are you guys in terms of setting up a Linux environment? So meaning, for example, how many people do use native Linux on their machines? 5, good. So it's roughly 10, 12 people. Cool. How many people use VM, some sort of virtual machine environment, like VirtualBox or VMware? Roughly same, yeah. Cool. How many people use the actual USB solution? Very few, good. Okay, that's all right. So, and the rest runs on Windows, or how does it work? Just, what's the state of play? Or haven't been able to make progress? Or what's the situation right now? Any feedback? Because I want you guys to actually run the cloud environment, plus also to play a bit with Linux as a response, you know, after this lecture here. Anyone? So, half of you guys don't have any sort of deployment on Heroku on Google Cloud yet, the Windows people? No? Cool. All right, cool. So we need to make that happen eventually. Good. So if you run VirtualBox, it's good. If you run natively, it's even better. The live USB stick requires you to do a mild adjustment of the setup. Yesterday, we noticed that you can't actually really run multiple users in a Linux live environment. In fact, you can. but you will need to create an additional user manually, which is a good exercise anyway, because we're talking about user management in Linux today, which you will need to do when you deploy applications. You need to, for example, have a service user that runs your deployed application on AWS or the like. So we need to be able to manage that as well. So I still want to continue with that bit and give you a bit more understanding about how the Linux file system works, how users work, so you actually know what you're typing. Right now, you're probably following relatively blindly the Heroku and Google Cloud tutorials that we put up from last week. And you hope that everything works the way it's supposed to be, but I'm not sure if everyone is really clear about what's actually happening behind the scenes there. So we want to set a bit more of a backdrop here in terms of what you're actually doing there. So that's why we'll talk a bit about Linux, and then we switch into a practical session where I help you guys with your individual problems, because I noticed some people struggle here and there. We want to figure that out. So, but first of all, one aspect that's specific to USB stick users, so it doesn't really affect the people that are using VM solutions on their machines or running Linux natively, because they most likely have a multi-user setup already. If you're running the live USB stick, you would want to set up an explicit user account. The slides are available on Blackboard, by the way, so you can easily retrace that. An explicit user account, which your system will log into afterwards. So you basically can do that by going into your console, press onto this tools button, this gearbox down there, and then there's the notion of user accounts. You create a user account. It's fairly reasonably intuitive. It's all numbered here. And the important thing is that the account should be an administrator account. What that means, I'll tell you in a second. Does anyone know what administrator means in that particular context? We talked about it yesterday. Anyone? What's the functionality we talked about yesterday? Yep. Exactly, right? So you have the sudo privileges, so you can run sudo commands. Doesn't mean that you are having all the privileges at any given time, but you can make them accessible or access them, right? So administrator here, and you provide a password. Note that this live USB environment requires a certain password complexity. So it took me a while to figure some passwords out that actually work, but this relatively simple solution kind of works. It wants to have some special characters in there, but use something you can actually remember. It doesn't need to be super secure because it's really for you mostly, just to play around with Linux, become comfortable, but something you would want to memorize and set up. Questions regarding that? Again, that's something you can do before you do actually the lab exercises that I attached as part of this slide set. But you should be able to easily retrace that in your live USB installation. Again, that's important for the people that are running from the USB stick directly, right? If you're running it in VMware or VirtualBox, then you don't need to have an explicit user set up because you already have a default user set up when you install it, right? So you call it something like user or default, I don't know. The system was asking you basically, and that would be your default user you would be using. But everything else should be the same, right? So you should have sudo permissions, that's the key, in order to manipulate the system. Any question about last lecture so far? It was shorter than I wanted it to be because I wanted to compress much more concepts in there. Because it's not a Linux course, yet we need to get the core or the principles of Linux across, right? Otherwise, you guys are, eventually getting stuck when it's getting a bit more complex. So I still want to get a bit more theory into you before we move into a practical part and actually have you set up your own proper environment. Cool? Okay? Yeah? Sweet. Some of you guys may have heard that everything in Linux is represented as a file. Who's aware of this metaphor? Yeah? Cool. Any, did you have experience with Linux in that respect? Or?
But I had the operating system first, so
Right. So, okay, what did you talk about there? Just to, so I'm not...
for instance, those folders are the files that so we can read through the file and find out, oh yeah, it links to this file.
Okay, so you talk about linking. So here was some mentioning of the Linux file system, how it's linked to each other, and how you can actually access folders that link to other folders, I suspect, or probably also devices. Did you do that as well?
And how one file system can be like hooked up
Yep.
onto another file system.
Yep. So how did you call that in the course?
I can't remember.
Mounting, perhaps?
Yeah.
Yeah. So file system mounting. Yes, that's a good idea. We probably won't be as deep as the guys in operating systems, but we want to get an understanding of how your file system structure looks like. What is the only folder you know right now, pretty much? The home folder, right? So what's the wildcard to access the home folder for any given user? Tilde, right? Yep, cool. Sweet. Cool. So there are various different ones, various different wildcards, so just be assured that we are on the same page. Cool. So the metaphor, everything is a file, and that's called the virtual file system in Linux. And it's in principle object-oriented, and it ideally makes everything, including devices, available as files. So you can modify them, read from them, use them for input, output, and so on. And that covers a wide set of different file systems in the first place. What are popular Linux file systems? For the ones that have some experience? Do you talk about it in operating systems, file systems?
Some of them, like Flash.
Yeah.
And GFS.
Yep.
I think they mentioned that one actually.
Right. That's cool. Yeah. So there are a variety of different files. Yep. There's some.
What do you mean by doing a file in like
That is roughly the idea. Yes. Exactly. It doesn't work in all cases. But for example, there is a random number generator, which is basically an executable or accesses the kernel directly. You can read from it. It looks like a file. You can read from it, and you get random numbers out of it, for example. Yeah. So that's the idea. It doesn't work quite smoothly in every context, but in principle, you can access files as devices. An example is the terminals. You can write to terminals, and if you do that, it actually prints output on that particular terminal. You treat it as a file. Yeah, we come to that a bit later, the principles, but that's exactly the metaphor here. Yeah, but it includes file systems, meaning you could write to Windows file systems, to Linux file systems, most notably ext file system, ext2, 3, and 4. That's various iterations of Unix file systems and some other ones. But also processes, for example, are represented as files. So where do you find processes in Windows? Only task manager, right? It's not much else you can use. That's the only environment you can find. In Linux, there's a task manager as well. It's called yep, htop. Yep. What's the default task manager in Linux? Yes, top. Right. So top is available in pretty much any Linux distribution, and just shows you the environment. In fact, I just bring it up briefly so you have an intuition of how it looks like. It seems to be wishful thinking here again. There you go. So, simply top. And it shows you a lot of details about your system, including a memory use, CPU use. If you're running Linux right now, just feel free to run top out of the box, no harm. If you want to quit it, again, it's an interactive tool. You need to press Q, right, for quitting. It's often the default character to quit any interactive environment you're entering, like the command less, which I will talk about in a second as well. Gives you an idea about CPU usage, memory usage, current processes, and so on. So that's the Linux way of inspecting your process use, but your processes are actually available as part of the file system. And it happens to be in the /proc environment. Can anyone read my stuff here that I'm typing roughly? Blue is never optimal, but the /proc environment. I'll talk about it in a second more. But those are all the processes you just have seen. And if you scroll up in that environment, you actually notice that there are some IDs there. And those are literally the process IDs that are attached to particular running processes. Yeah? Each process has a unique process ID. Cool. Right, so that brings me to the layout of the file system. So that's not something you want to learn by heart, but you want to have an intuition that there is something like a file system hierarchy standard, and you would want to know the most commonly used directories. So not every Linux has all those directories, but those are the ones that are designed for particular purposes. So the ones of you, so which one did we explore at this stage already? Which directory should you know? Home. Okay. Anything else? Yep. Yep. Right. Cool. So Etsy is really one of the core folders because that's actually where you do any configuration modification. If you're customizing your Linux system globally, system-wide, it's most likely happening in the Etsy system. Also, if you install software, when you're wondering where to configure it, my first guess would be the Etsy folder. Now, even if you don't look at the documentation, just browse the Etsy folder, look for the service or application name, and most likely you find configuration there. But I'll just walk through it from top to bottom roughly. So common user binaries are in the bin folder. Bin is kind of a conventional subfolder for most compiled services. Then boot, this contains all the files, the different bootloaders that are available. So you could, for example, boot into different kernels in a given Linux environment. You recall that you have this boot manager at the very beginning, especially once running from a USB stick. And this is precisely where you could allocate different images that could be booted into different kernels, for example. You may want to run an older kernel for reliability and a newer kernel for development and explorative purposes. So you can freely select, that's the key idea. /dev, that's the interesting bit. Those are devices. So that's basically a mapping to devices in the operating system. That's actually quite interesting because it includes mouse devices, keyboard devices, your hard drives as well. Probably can just briefly do an ls on it, just to give you an intuition. We come back to that in a second. You notice here, for example, TTI 0, 1, 2, 3, 4, and so on, right? What was TTI again? It's a terminal, right? The terminal you're interacting with. They're identified as TTIs as well. So then there's a random number generator I was just talking about briefly, random, and so on. So it's various devices that are actually attached. FD is pointing to the floppy disk. I'm not sure if we have that really. So again, I'm currently working this Ubuntu Bash environment, which is rather constrained. So you don't see as many devices as you would in your conventional Linux installation, right? So something a bit more constrained. But in principle, you find a wide range of different devices here. Yeah?
Can you cut the random?
Sorry?
Can you cut the random?
You can read from it, so you could use it in a script and then read chunks of it. So that's what would be an option you could do.
You can't write cat.
If you do that,
So I can't test it myself.
let's see what it actually splits out. Yeah, it splits out the stream. So an encoded stream of random numbers.
Continuous.
Yes. So you need to terminate that properly and deal with this. So before I have some sort of overflow here. All right. But in principle, you can read it as a device, and it should produce random numbers. Yeah, cool. So I wasn't done yet. So we obviously have the home folder, right? And home folder has subfolders like home user 1, home user 2, and so on. Everything specific to user should reside in those directories. It also means if you are modifying something without using sudo, you should never be able to affect the system, the global reliability and robustness of the system, unlike in Windows, where you can quickly affect system-wide configuration or performance. The home directory only contains regular users. There's one exception, which is the root user down here. The root user's home directory is separated from the conventional home directories. Any intuition why this would be the case? Why is that a good or bad idea? The root user? We talked about mounting. Yep. Yeah, exactly, right? So the root user has a special environment that's dedicated for its data, basically. But thinking about mounting, we talked briefly about the idea of mounting different hard drives. What would be the advantage there, separating the root from the rest of all the home directories? It's an open question to everyone if you want. Well, the idea is that you can, in any of those directories, you can actually mount different partitions. Yeah, so you have different hard drives, right? And the main root hierarchy is mounted on the first hard drive that you have. But for example, the home directory is mounted on a second hard drive that you have. So actually, you may want to contain the root information along with the system information, because most likely its purpose is to, configure the general system, but also think about aspects such as recovery, right? So, and that's all the case where the user home directories don't really help. Secondly, you may just want to separate user data and keep a separate backup from the actual system backup, right? So you can quickly spin up another system, but it doesn't mean that you replicate all the user's data. You just hook in existing user data into a newly spun up system, for example. That's a bit more involved here, but there's a reason for actually separating those out, which makes sense. So libraries, what else? We have some media mount points that by default mount points such as disk drive, USB sticks, and so on reside in there. So you can access them using that directory /mount/USB0, for example. System binaries, which are different from normal user commands. So those are more for system manipulation. And then servers or services here, this is found in some distributions, but in all. Temp files, obviously. And everything that's installed by the user, but it's generally binaries, and it doesn't really change too much. It would be under user/user local in particular. So Go, for example, sits under user local. Yeah? You installed it using a user, but it's in principle globally available, and it doesn't really change once you install it. Right? If you have variable files, they sit under /var. What are variable files in an operating system? Any idea?
Like environment
Not quite what. That's their variable, I agree. That's not quite quite the understanding I mean, but where would user-specific variables probably reside? Where would they sit? Anyway, but on the hard drive right now, assuming shutting down your machine, where are they stored? Var, okay. Another option? If they're user-specific? Right. So not quite in user, but rather in their home directories. Yeah. So if you log in as students, your environment is set up. If you log in as Linux Gym, for example, it's a bit of an odd example, then all your environmental variables would be set up. But it's a good point there. No, what's more like variables would be log files. Yeah. So services and continuous log files such as the syslog. Did anyone explore the syslog before in any context? Because he or she ran a private web server or something like that. Because it's usually a starting point for exploring diagnosis in the right sense. So varlog is generally good for location for that one. You will explore it hopefully as part of the task that I give you afterwards. And then we have the root directory and the proc directory, as I mentioned, shows all different processes. So this is the file system hierarchy in Linux and Unix system. If you know that thing, you're pretty much able to navigate around in any Unix and Linux system because it's standardized. And that's the key idea here. The Linux one is slightly expanded, but that's the key principle. It doesn't really change. So that's something that's worthwhile bearing in mind for future purposes. Cool. So just to move on rather quickly. So assuming we have a system path, and generally the system hierarchy always starts with the /, which is called the root. Yeah. So if you, for example, do cd/root, you end up in the top level of the very hierarchy. Let me bring up Linux again, and we'll see that. So right now, I probably need to restart my environment. Yes, I need to. I think it's reset the encoding to some extent. So let's give another one here. There you go. So if I type cd/cd root, right? You notice here that suddenly my home directory is actually root. Remember last time or yesterday we talked about the user prompt, how it looks like. Again, that's the user, that's the machine, that's the directory I'm in. That indicates if I have normal regular user rights or super user permissions, and that's obviously the prompt. So now we know I am in the root directory. If I press ls, I'll make it a bit more visible, hopefully. So you roughly, with some variations, again, there are variations in different distributions, you see this hierarchy, the hierarchy standard that I just showed you, right? So we find things like boot, bin, dev, etc, home, and so on, right? So all those different folders are available here. So if we want to navigate between different folders, there's two ways of doing that. Assuming that this is a system hierarchy here right now, we have the concept of absolute path and relative path. And to do this, we kind of need to know what different parameters stand for. For example, dot stands for parent directory. Whatever directory you currently in, dot is the corresponding parent directory, and dot is the current directory you're dealing with. For example, if you're running an executable in the current directory, by default you would type something like that. Dot, left, dot. And then the executable here, right? So current directory and the executable name. Right. If you want to run an executable in your parent directory, you would do something like /exec. Yeah, would move one level up and do it in the next higher directory. If you want to run something in your home directory, how would I do it? Just checking. Tilde, right? So quite straightforward, tilde, and then the executable would run it in your home directory. Cool. So that also opens you new options to navigation. Number one, you could do absolute navigation. For example, what's the absolute path of the folder October down here? Yeah. Can anyone tell me the absolute path that you would describe? How you would describe the location of that folder? Yep. The October one. Just look at the lower slash. Yep. Yep. Cool. Cool. So what's the difference between absolute and relative path? Does anyone know that already? Yep. Yep. Yeah. Cool. That sounds good. So yeah. So it's the relative path. So you could, for example, assuming I'm borrowing your example, assuming you are currently in the directory gym, writing assuming in the directory gym, it would be something like, well, you could either say, to be explicit, you could say /calendar. So in the current directory, look for the subdirectory calendar, and then the directory October to actually get there, right? So not very visible. So /calendar and then /October. So would be able to navigate down to October from the directory gym, for example. How would I navigate from, let's say, October to sub? So from October here to sub down here. Yep. That was fast. So slash. So sure, you can do absolute path. That would be cd/home. Exactly right. In this level of navigation, you probably safer doing it to the absolute path. But it really depends on the layout. What could be an advantage of using relative path over absolute path? But thinking about your own application, for example. So it can be for conciseness of navigation, but also think about deployment. The server file system setup or the server structure may be different from your local one. So if you work with relative path within your local project, you'll be free, right? Because the conventions using dot and /slash will work. But you may not know the absolute navigation path from root. Does that make sense? Yeah. So if you, for example, writing your application Ubuntu environment, you actually need to deploy on a Fedora one or a Red Hat one and so on, then it may actually fall over. That's why it's quite important to get that right, get the understanding between Absolute and relative file. Is that clear to everyone? Who is totally lost here? What are we doing? And stuff like that. That's fine. No, you can ask me afterwards what you're trying to speed up, but it's very, quite important to actually understand that concept because you will see it again and again. Also, once you know those variables, you understand the intuition of many commands. You know, many commands will say // and then command name and so on. You know what it actually means. So that's the idea there. Cool. So in order to actually create files and directories, we have various ways. Generally, I organize those kind of modification aspects by the CRUD acronyms. What does CRUD stand for? You guys know that, right? CRUD? No? C-R-U-D? Please forgive me, I don't know your curriculum by heart yet. That's why I'm asking those stupid questions, because I want to know what you guys know, what you guys don't know yet. So, but anyone come across that? C-R-U-D, CRUD? What does it stand for? C-R-U-D? Yep.
It's for basic operations. You need to have to do anything with a file system.
Cool.
Or a database.
What are they named? The operations?
Create, read, update, delete.
Cool. Yeah. There you go. Right. So CRUD operations. So that's basically how it's organized. There is a claim that nowadays we should have SCRUD operations. What would be the S standing for?
Secure.
Search. So it becomes more and more important to search for large file systems. But those are the basic functions. So that's why they're organized this way: create, read, update, in the widest sense, and delete. So, and for files, we have, if you want to create files, we can use the touch command. So the touch command creates basically an empty file. It's an interesting property. If you just need to create a file for whatever reason, use the touch command. If the file already exists that you're creating or trying to create, it will just modify the timestamp to the current point in time, right? So it won't change the content and won't delete the content, but it will touch the timestamp. Similar, this one here is redirection. You may know that from MS-DOS or from batch files, or I don't know, from somewhere else. It's a redirection of content from the left to the right. So basically you can write file content directly. You guys, are you aware of this, or is that new? Common knowledge? I don't know. I'll just briefly do it. So you can do something like that. What I did here just now was echo test, meaning take the string test and redirect it into a test file. What will it do if you run cat, which is the command for inspection? I'll show you in a second. You can actually see the content, right? If you want to append content, you use the double redirection. So if you do this one, it will append to the existing file. Now you have two entries basically there, the original test and now the newly appended test. If you do the single redirection, note that it will overwrite the content. If we look at the test file again, after running the single redirection, there's only one test string in the file. Make sense? Cool, yes, easy, good. Okay, cool. Yeah. Sweet.
Can you
yep.
create new files based on existing files in the same way?
Yeah, which command would you use intuitively? Copy, right? Yeah, so exactly. So you can, yes. Cool. So, and that's precisely, we get to that in a second. So for viewing, there are various commands I want to highlight. They're really powerful in Linux. In Windows, you kind of, it boils down to double click or edit, or whatever else you have at your disposal. But since we are on the command line mostly, those are the important commands. There's cat. Does anyone know what cat stands for? Yeah. Okay, that's right. That's right. The intuition of this cat basically means catenate. Yeah. So concatenate, you know that. So and you basically can concatenate multiple finds and printing the output to the standard out. Then we have some other commands like head, tail, less, and cut. Those are for inspecting rather large files. Imagine you have a log file. I'll just print out a syslog to give you an intuition what. This environment doesn't have a syslog. but I printed some other log file that I'll probably find. Cool, let's do a cat on the D package log. That's not too long, but still, it goes for quite some time, right? So, and you will be able to shorten that considerably if you're just, for example, interested in looking at the first 10 entries, which you can modify. So you can introduce a parameter -n, and then, for example, show the first 100 lines if you're interested in that. And similarly, tail operates the very same way. So it only shows you the last 100 entries, for example. That can be very handy if you're looking at inspecting your own log files and so on. If you want to have an interactive tool to navigate your file, try using less. So less is actually a tool that is interactive, but you basically can navigate around using the cursor keys, and you press Q at the end, simple Q, to actually exit, so you're out of it again. So that's the other tool I want to just highlight briefly. A tool that has special function is cut. And this one basically extracts columns from particular output. For example, if you're interested of all the output only in the third character of each line, then cut is your tool of choice. You can basically extract that quite straightforward using that. Cool. If you want to rename files, you use the mv command. Yep, sorry. Question? Basically, for example, let's try something. So that looks rather useless right now, but you don't see anything. I did it for myself. Beautiful. So, right. So I just typed cut -c1 add c pass double d. Add c pass double d. What does that file do? Anyone? Who did the quiz? You'll get into that file more and more. It contains all user information, right? So add c pass wd. This shows just the first character of each line of that file. I'll show you the file in its complete beauty. And C1 is just the first character. If you want to just have the third character, you would enter 3, for example. You can also have ranges 3 to 5. So only character 3 to 5. So usually it's basically a complement of head and tail, because head and tail orders by row. So you can take the top 10 rows or last 10 rows. But this one is by column. So you have an opportunity to actually navigate files by column. Okay. Okay. I think I misunderstood indeed. Yep. Sorry. The directory, just navigate me. This one? You mean the layout here? Okay. I'm mapping the corresponding, how do you view directories or something in directories? How do you view files? It's different, right? File content as opposed to directory content. That was the intuition. Sorry, if that's not clear. So it's basically, how do you create a directory? How do you create a file? How do you look at files? How do you look at directories? How do you move or rename files? How do you move and rename directories? Change, and how do you delete both of them? Yeah, because it's fairly analog. You see a lot of similar functionality, but sometimes it depends. Obviously, for files, view in particular. Okay, cool. Sweet. So cut is basically also one viewing option. For directories, we know already. If we want to view the content, we use ls. Yeah, this is the content of directories. Moving files and renaming files is mv. Stands for move. Yep. 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 So it's yeah. Right. Very nice. Nice. Cool. Yeah. That sounds good. Yeah. just to bear in mind, this, unlike in Windows, moving and renaming is the same function, right? And what's in Windows? Do you guys have some batch scripting or somewhere? Did you do that stuff? What's the way of renaming files there? Yeah, exactly. It's two different commands. One is move, the other one is ren for rename. And here's the same thing. It's important to remember. Yeah, renaming and moving is the same thing, and technically it's the same thing anyway. So just changing the name or location, because the location is part of the name technically. So from that perspective, it's okay. So another variant is obviously CP, stands for copy. Unlike the Windows copy, it's CP, quite straightforward. And appending, I showed you already, if you want to append something to a file, use the double redirection tool. Deleting RM for remove. And for directories, you need to use -R. Yep. Yes, correct. Good. So in most commands, if you find a capital -R, it stands for recursive. That's kind of a convention across most Unix tools. Yeah. So you don't use it with files. If you try to delete directory with RM, it will not allow you to do that unless you start using recursive. It means it deletes. What does it mean actually, recursive in that context? That is correct. So it basically deletes this entire branch below that directory you're currently pointing to, or you're signifying, and then basically delete the content, right? So including all files.
I'm just wondering about append adds also an end of line.
Yes, in this.
Append that two times twice.
Yeah.
String and it's adding the end
Yes.
of file and end of line.
Yes. It adds the end of line, the Unix one, \n. Yeah. Cool. Yeah, you're right. Yeah. Escape character, the end of the string. Cool. One thing I still want to highlight is the idea of links. So if you want to link between different files, that's the syntax how to do it. So LN stands for links, -S for symbolic links. There's also a variant called hard links. I won't talk about them because that spend too much time on it. And then you identify the target file and the shortcut file, basically, right? So target is the file you're linking to, and link file is the file you're linking from, right? So it's like a shortcut in Windows, the equivalent. And it would look like this in the console output. So ls-lisa would produce something like the output you see here, that the link file actually links to the file test that is sitting in the very same directory. Yeah. Cool. Unlike hard links, which I'm not exploring in depth, they're actually two distinctively different files. Hard links can have especially two pointers to the same memory block, which is kind of different. It's a very unique concept in Unix, but it's discouraged because it doesn't work across partitions. So the soft link is the way to go. So in case you need to create a soft link, which I'll ask you to do in the labs later, that's something to look at. Cool. So a few important files I want to highlight. etcpasswd. It shows us all the user information. So if you're not sure which user you actually have in your system, do a cat on passwd. It's generally not big. It's like, I don't know, 20, 30 lines, because there's a lot of system users. And you should see all the installed users. So that's your way, and that's also how Linux basically manages users. It's all happening here. And those columns signify the following. First of all is username, then column separator is colon. The next one is password, which is obviously not your password because it's hashed in the file scshadow, which we don't need to talk about. And then user ID, group ID, and the third column I forgot right now to look it up. And the last two columns are the home directory and the default shell. Remember, we can have multiple shells in a Linux environment, and each user could have a different one, so you need to be explicitly specifying the shells. You see a lot of them that have a shell called bin false or no login. Those are basically service accounts that you can't explicitly log in from. They're just sitting in the background. For example, if you're running your system log, it has its own service. If you were to run your own MySQL server, it would have an own service running in the background. with very limited permissions, but you wouldn't be able to explicitly log in, right? It's not an explicit user account. Another file I want to highlight is the file etc group, because you will have a look at this as well. And it contains all the groups in the system. That comes to us back to us later when we'll see what's happening. So you basically find here all the individual group names, and then as the last column is the identifier here. And if there are multiple members to a group, such as here, then there's also a list of users that are members of a given group. So I come back to groups in a second, but just wanted to show you those files. Those are, I think, among the most important files in Ubuntu systems. So etc passwd, etc group, and var log syslog, the syslog. If you're running a service in your machine, Apache web server, and you don't know what's happening, and it's not starting, that's probably a good starting point to look into it. Yeah. So, but obviously they may have their own log files, like such as access log or whatever else. But that's a good generic starting point. You will find most log files, in fact, in this directory var log. That's the key idea. Cool. Sweet. So before. Yep. Sorry. Question.
I was just wondering if you're planning a break.
Yes, I plan break now. I was just thinking about it. Let's break a bit for until 12:15 if possible. Yeah. Be back. And a bit more painful agony here with me, and then you're free again.
For 3 more hours.
Oh, really? Okay. 3 more hours.
Yeah.
Right. Okay. So, probably, how are we doing? So we go to something like that, so we get up so you know how I do it. You can tell me what you did. And we'll see if it works. It may also be. I don't know. We'll try. Let's have a look.
It might be USB stick, it might be its name.
What am I doing wrong? Well, that's tight. How do you? Right. Oh, it's super tight. Okay. So let's see. Where do I have this? Let's see if we do the same things. I agree. Ubuntu. Look at the image, which I have somewhere. I'll come to you in a second.
I need to check.
So it doesn't run?
I tried, but I couldn't get it. I don't know.
Let's try English first and see if that works. Perhaps it doesn't work, then we don't need to try yours, right?
Okay.
Yeah. So, but it's still mucking around here.
Okay.
I don't know what's happening here right now.
Is your computer slow?
Yeah, apparently, right? It shouldn't be. I suspect it's accessing some network or trying to access some network functionality. Come on, time for this. So there you go. That shouldn't have taken that long. So 1604 desktop image, right?
Yes.
Similar. You probably have the same one. We finally made it. So we find your flash drive with 59 gigs free. Looks good. Cool. We make the maximum available. Shall I erase the content before that to have it clean?
Yes.
Yeah. So good. And off we go. Okay. Are we sure that's the right one? Let's double check. Don't want to delete my own hard drive, right? Do I? So, cool. All right, that will take it. No, that's not. This is pretty fast.
It's fast. Upward big one. Just because of speed.
Right.
Not because of big
Size,
gigabyte
right?
size, but
Yeah.
because of the speed.
That's good. No, that is fast. Yes. Oh, there you go. Let's see. 13, 17. I should have used a different one. It was a bit slow, but it worked. So I just said that was the only one I had at hand. So, but yours is really fast. Yeah. Cool. So let's see if we get further, and then I will help out over there. See if we can do the same. So, acceleration data. Now it's creating a persistent file, and that's the tricky bit.
If it casts snow, it's
Yes. So you're having a Lenovo laptop, right? So can't you press, what was it? I think F12 or something like that.
no, it didn't work.
Didn't work.
I have to go
So Windows.
inside Windows and go to put it's feeling the size higher.
Yep.
It's going to be
Right. I'll come in a second. But first go to one of those guys and then you are the second one, yeah? See how long it takes.
it's as fast my computer.
Yeah, that can be suspicious as well. Because it should be, I mean, this machine is pretty reasonably recent. Would surprise me if it's that slow, really. But come on. I'll just let it run for now. I'll just help out over there and see if it's done. You can just finish the tool and just pull it out, or how to do it, right? But I'll be back in a few minutes.
Ja, shitworks. Jeg klarte å lage en ny sudo-bruker. Klarte å få Captex. Hvordan installerer program på terminal? Ikke bare command-line. Er det en egen? Ja, det var disse. How did we know? Nei, ja, vi må legge inn til en liste, men den finnes der ute.
Ooh, the next labs.
Det her er jo så mye bedre enn jeg var.
Why am I using that kind of word?
Det hadde jeg på to, ja. Ja, det var bare det han pleier å slå der i blant. Swing. Som et som skriver ja. Jeg skriver med høyre, så egentlig burde vi bytte plass.
Okay. So 12:20. We have a few more minutes left. So I noticed a few different challenges here and there. By the way, one word of mentioning why we're using so much command line. Any intuition why we do that? Yeah, but why is it important? That's correct. Much faster. What's another reason?
You don't have a desktop servers.
Less mistakes, yeah or not? The comment here was really good. Well, just repeat it, please.
You don't have a desktop on servers.
Exactly. AWS and Azure, if you run your Ubuntu version there will be no desktop environment there. So you won't have it, but that's what you want to say.
There are many tools in the terminal which don't have an equivalent.
That's correct.
In desktop.
Yeah. So why is that the case?
Because developers tend to spend most of the time in the terminal.
Okay. So yeah, we get back to that one. So was it? You feel like? So there, you're talking about two important things. So just yep. Okay. Yep, exactly. So there's all the important points are here. So number one, you can actually program using the tools. You can't really use the GUI interface and program against it unless you do some screen scraping or some weird stuff. But you know, all those tools we're looking at here, you can actually use them in your programs productively. Plus, they have so many options, you won't be able to develop a GUI for them, you know, because it will just blow over. If you look at the help of some of those commands, there's so many different options, it's impossible to do that. And the other aspect here was remote control. You can remotely execute it on different machines, yeah, and it's relatively cheap from a bandwidth point of view because you're just transferring command line interface as opposed to a fully fledged GUI, right? Who is interested in the nice logo on the top right that was, you know, introduced there because of vanity reasons of the developer, but it's totally irrelevant for your productivity on the command line. So we need to do a lot of stuff on command line, and in worst case, simply because we won't have a GUI. Even if we wanted to, we most likely won't have a GUI in AWS or Azure or, well, it depends on us, but generally not. So it's much more resource consuming to have it. So previously in the beginning of the slide I showed you how to create a user in Ubuntu Live. Here's how to create a user on the command line. And I show you two different ways. And the reason is that one is the proper approach that you would want to do if you do scripting. The first one in particular, it explicitly says user add -d stands for home directory, and then you obviously specify the home directory. -m ensures that it actually creates the home directory when it creates the user. If you forget -m, it won't create the home directory. It just says there is the home directory, but if you try to log in, you get the first error thrown at you because the folder doesn't exist. So it's not really explicit about it. But there could be an advantage. For example, you are importing the file system from a backup, for example, but you need to set up the user again. In this case, you don't want to recreate that home directory, but just use the existing one. So that's why it's quite important to have that parameter. All those Unix commands really think about those particular intricacies, and you can model them explicitly. So then there's -s, that stands for shell. So that's where you specify the shell that the user is presented with. Right? Bin bash, for example, the bash shell we have been using. And then obviously final parameter is the username itself. Yeah, this is one line. I'd ask you for passwords though, but it's basically superscriptable, whereas this one is not. This is like a wizard. That's the easy way out. Add user, and then you type the username, and we'll ask you, heaps of questions. But it basically does everything for you, which is convenient. But again, similar to GUIs, you can't script against that thing, right? Because it's dialogue. Whereas this one is a simple one-liner and tells you whether it worked or it didn't work. That's why I want to show you both variants. Cool. And the information of that is actually stored in etc passwd. Question now, if you create a user, do you need to use sudo or not? Trying to create an admin user or are an admin user?
No, if you're not that user, try to create it, then
No, you can't. You're right. You're right. So right. But if you're assuming hypothetically you're somewhat in control of your own system and you want to create yet another user, would you need to use sudo or not? Is it a system-wide change or is it just on for your own new user account?
I hope so.
Is it a yes or no? Oh.
Yes.
Yes, it's a yes. Yeah, yes is correct. So adding a user is modification of the system environment, particularly because the user information sits in etc. Everything you do in etc generally requires sudo permissions. Yeah? Unless you set very loose permissions, which we'll talk about in a second. But etc is general configuration files, therefore we need sudo to actually do that. You can also log in as a different user. So first of all, we learned about sudo, which is do something as a super user. The prerequisite for that one is to be member of the group sudo. So any user who's member of the group sudo has the super user permissions. But it actually is quite powerful if you want to, if you are super user, for example, and you want to emulate another user, you can just write su and then the username you want to impersonate. Su stands for switch user, and run it as this. To exit, you just type exit. Note that those logins are basically nested. So if I, for example, say su user2, let's say if I have one here, cool, I have one here. So you saw me what I'm not sure if you saw what I do, but I can tell you what I did here. So we see I was logged in as user at NTNU and so on. That's my machine, and I impersonated user2. So I said su user2, and you see the next command line. I'm user2 now, right? And I could do, if I have a user3, see if that works. Ah, cool. So I set the users up beforehand, that's clear. So, but if I want to return to my own console, I just type exit. So it's basically nested shells. Yeah, I'm logging in from my user to the second user to the third user. If I'm now typing exit, I'll be returning to the second user. If I type exit again, I'll be returning to my original user. Yeah, so bear that in mind that you're logging in on top of your current shell. It's not a replacement. You're not logging out of your own shell. You're just logging into yet another one in addition to yours. Yeah. Cool. It's actually very nice for scripting, so you can jump between different shells without losing your login. Cool. Another thing we need to talk about is groups. So I mentioned already there's a file called etc group, and it actually maintains groups, and each user by default is a member of one particular group, his own private group. And the reason lies in having the ability to manage permissions on a group level. We get to that in a second. So by default, each user has a primary group and one or none or more secondary groups. The primary group is particular to that very user. For example, if you have an own file and you don't want to share that file with someone else, you just make your own group owner of that file, and therefore only you will be able to manipulate this particular file. This group name is shown in etc passwd. Any additional group is shown in etc group. You can be member of multiple groups, obviously. Yeah. So those would be considered secondary groups. I'll show you an example. If you want to figure out which groups you're actually member of, just type groups on the command line. Groups, yeah, should work. Note, if you change group memberships, you need to log out and in again for them to take effect, or at least for them to show up in the groups command. This user here, so user is member of the group's user. That's his own group. Why is that screen doing stuff? I don't know. Okay, cool. ADM, standing for administration, CD-ROM, meaning that user is actually allowed to access the CD-ROM drive, whatever that may be. sudo plugging in devices dip. I'm not sure what it stands for, and that's, I think, it's virtualization, running virtualization services. But the essence here is that this user is member of sudo, meaning it can run the sudo command. It can impersonate the super user or run commands as super user, meaning install software, for example. Yeah. Whereas, for example, user 2, I'm not sure if this user has this permission, may have very different permissions. Yes, this user, for example, is only member of the groups user 2 and sudo. Again, has sudo power, but it can't do many of the other, a lot of this other functionality out of the box. Yeah. I just show the etc passwd again. And to clarify how this all links up. So we have the user ID, the password we don't use, then is the, sorry, the username, the X for password, and then the user ID, and following that is the group ID. For example, for the user 3 right now here, we have the user ID 1002, we have a group ID 1002. So if you look at etc group, you guys had databases, hopefully, or having database right now, you know what the primary key is, right? So, so if you look at the file etc group, you see the corresponding group ID here. So user 3 is the group name, and you see that the identifier, the third column, is 1002. So that's how those two are basically linked, yeah? So each user gets an own group by default. But if we go up, for example, hang on, where's the sudo group? Here, you know, see the sudo group over here? It has two users attached to it. So that's why you specify the secondary groups, secondary users. But I obviously share the commands with you how to actually change it. But this is one way of figuring out who is actually member of sudo, the sudo group, in this case user and user 2. So that may not make a lot of sense right now, but it will make in a second when we get there. So the commands of changing associations with user groups, I just leave them there in the slide set, you can explore them later, is user mod dash lowercase g to change the primary group relationship of a user, and capital G for secondary groups. If you want to append, meaning add the user to yet another one, you need to use the command user mod dash a dash capital G, yeah? Append to the existing group. Otherwise, all the secondary group associations will be overwritten. Yeah. Cool. Okay. Sweet. Something else. Environment variables. You briefly dealt with those ones. So in your environment in Bash, before I get to that later, you can register environment variables. And you did this for Go, Path, and what else did you register? Which ones? Which other ones? Which other variables did you play with? Environment variables? Path, perhaps? Capital path, you know, you're appending elements to that. So we need to understand what this is about, because again, it's important for a user perspective. All right, it's a bit of a jump. If you are logged in as a particular user, I just moved to the home directory right now. So, cool. You find you can run the env command, env, and it stands for environment. It shows you all registered environment variables here. You see some interesting ones like home, what else? Host type, so it tells you something about the type of your system you're dealing with, but also the massive path variable. And this basically are all the different directories on your machine whose commands or the files that are accessible globally. So you can actually run the commands contained in those directories from any location in your system. Yeah? That's why we put the Go executable on the path, meaning we can run Go from anywhere. From your home directory, from the root's home directory, from root itself. It doesn't really matter. We don't need to navigate and explicitly indicate the full path. Yeah? So that's the path variable. And various other ones that we find here. If you want to explicitly show a given variable, you just use $ and then the variable name. For example, echo $path. It will just print out the current path variable that you're having. Okay? So if you want to add and modify your own variables, you would want to do that in the file .bashrc that sits in your home directory and is read every time you log into your system. And you notice at the bottom here, I added some export statements. Those are basically the different variables that are specified upon every start, in addition to the ones that already exist. For example, gopath, the path extension. So you're basically extending an existing path variable by simply using $path separated by colon, and then the extended path that you want to add to it, and assign it to the path variable. Notice that an assignment happens without $sign, whereas the dereferencing the use happens with $sign. It's a bit confusing. It's a bash convention you need to live and work with. Yeah. So this way, so we are assigning path, the path variable, the original path variable, so all the existing paths already, and an additional new one, which is the Go binary location. Yeah. So this is managed in .bashrc. Cool. So it's described here. Last thing I want to talk about is permissions. Permissions is a big topic. Unfortunately, that's why we still need to explore that. So, if we, yep, sorry.
Like the hash on the second export.
Ah, right. I commented this. It's not executed.
Okay.
Yeah, so that's a good point. In Bash, if you want to comment code, you use the hash command, so this line is simply ignored. It's usually for commenting, obviously, but in this case, I simply commented that because I was mucking around in my book. So, yeah, cool.
It's also worth noting that
Yeah.
because of having the hash variable, most of your plans in the kernel will be on. So if you override hash,
Yes. Yes. That's a very word of caution. Did it happen to you? Or did it happen? No, okay. So if you overwrite your path variable, you're kind of screwed because you won't have access to most of the commands you're actually executing. Because unlike in MS-DOS, where they're part of the kernel itself, so directly built into the thing, here we're dealing with executables. And they mostly sit in the bin directory or user sbin directory and so on. And if you don't have those directories on your path variable, they're simply not accessible. Yeah, so you simply won't be able to access any of the executables we're using, like ls, cp, mv, and any of the commands we're exploring. Very good point. Very good point. Indeed, important to note. So I just typed ls-la, and the options -l and a stand for give me all output, and l stands for long output, meaning I have a column output, which is a bit more legible. But the advantage is also it shows you actually a permission set. If I run ls simply, I just see all non-hidden files, which happen to be this one and this one, because those are the only ones that don't start with a period, with a full stop. Full stop means hidden file. So those are visible, but it also shows them in some sort of kind of list format here. But here it's more like a column-based detail format, which is more helpful. So if you look at this, at the output you're getting here, you have something like modification date, you have something like size, and then on the far left there's something else. And we want to explore that. Does anyone know what this stuff on the far left means? Yep.
whether it's like directory, whether it's read, write, execute, and
Yep.
which user or group is allowed to do these actions.
Yep, cool. So how do you see whether it's a directory or not?
If it's reading D, then
Yep.
it's like directory.
Cool. So you notice those 10 bits there, basically, of meta information on the far left that are attached to each file individually. And the most left one, for example, in the case of .cache, it reads D, similar for the .config, where in most other cases it's just the normal dash. Yeah? And D stands for directory, dash for regular file. There are some special files, I'll get into that in a second, but this is the way of identifying files as directories. Yeah? ls-la, and look at the details. Following this are 9 further bits that are the permission set. And they correspond to the owning user and the owning group. So yeah, please.
I first read it as the 512 largest. And then I realized that's probably the size, so it's not the
Yes.
size in kilobits or megabytes.
Right.
Bits, right?
Bytes.
It's in bytes, byte size in bytes. Yeah.
You can have them, I think, in the MA with the using readable.
Yes. Yes. That probably you're right. There's H. Yeah. Yeah. There you go. Now we have human readable output. Perhaps that's used better.
Yeah, that's
Good point.
kilobytes.
That is now corresponding to the. This will be in, I think, still in bytes. This is megabyte. This is kilobytes. 1 kilobyte. You know, it signifies explicitly, but it's human readable. It's not good for parsing in scripting context, but good for presentation. So that's the H command. Again, so it's worthwhile exploring the help for any command, you know, to suit it your needs basically, and introduce it as an alias into your environment. So ls, for example, you can override ls with the alias. So it always has those convenient options enabled. So, but back to the permissions, because it's something I want to get through. So the way the permissions work is that we have permission set of for an owning user, a permission set for an owning group, and a permission set for everyone else. Yeah, user, group, others, UGO. That's the key idea. It also means that a file has an owning user and an owning group. So that's the user, and that's the group. Again, notice that the group seemingly has the same name as the user. That was the thing that I referred to earlier with primary group. Each user has an own group, but since we need this group assignment for the permissions for all files, we need to have a default group. And that's the user's private group, meaning by default only the user has control over that file. That makes sense, right? So if I use, for example, the hypothetical group users that would encompass all users, it means that all users suddenly would have access to that file, which shouldn't be the case, only if the user wants to do that. Right? And then there's all others. This would be the last 3 bits here. There's no specification of others because it's everyone else, literally, that is available. Cool. So conceptually, it's sometimes confusing. So I would show it in this way. So if you briefly follow me here. So again, the first bit indicates the type of file you're dealing with, generally directory or regular file, but it can also be an L. L stands for symbolic link, a B, which is a block device, and a C, which is a character device. So block device being a hard drive, character device. What's a character device? Please. Yeah, character device. Which device?
Oh,
Keyboard, right? Character device. So it sends individual characters as opposed to block devices that sends chunks of data in a fixed block size. So again, this comes back to the virtual file system. Everything is represented as a file. But this is how you figure out what it actually is. There are a few other ones. But what's more important here is the permission set. So the first 3 ones here, first 3 bits are representing the owning user. Then the second 3 ones, the owning group. And the rest is others. Yeah? UGO. And basically, depending on how this bit is flicked, it will indicate the permission set for a particular combination of users or a particular user. And the octal representation is basically just derived from the positioning of the bits. So the execute bit is 2 to the power of 0, therefore 1. 2 to the power of 1 would be 2, which is for the writing, and then the 4 to correspond to the reading. Why I'm bringing this up is that most people confuse 2 and 3. So if you don't know the underlying intuition, people will get confused with respect to the underlying character. So if, for example, your owning user has the permission to read and execute, those 2 bits would be flicked to true. And we would basically have a decimal representation and say, take the sum of those, which would be, what would be the value for a user that has read and execution access? Yep, 5, right? So 4 plus 1 and so on. So basically that's your way of determining the octal representation for the permission set. We do that for users, group, and others. Yeah? So that's the whole idea here. So the least permissive set would be 0, 0, 0, meaning no permissions at all for no one. The most permissive one is 777. Everything is available for everyone. That's not a recommended permission set. So it's easy way out. Just set everything to 777 so everyone has access. but it's a very unsecure, unreliable solution. Yeah, just bear that in mind. But that's basically the idea here. But if you mentally iterate through that one, right? So what if this is the octal representation? What would be the permission set for 0? Well, I talked about it. No one has access really, right? So what would it be for 1? Yep. Execute. Yep. What would it be for 2? Anyone else perhaps? Anyone who didn't have operating system yet? Yep. Write only. Yep. Cool. So it would be write only permission set. And a 3 would be then? Yeah. Really? Okay. Write and execute, right? So it would be the second bit and the first bit. So 1 plus 2, 3. Yeah, cool. 4 would be perhaps from this corner here. Anyone? Read only, right? So only read. Cool. 5. Read and execute, right? So R and X would be activated. 4 plus 1. 6 would then be. Anyone? Read and write. Okay, cool. And then everything. So that's the possible permission set that you can represent. Yeah. So that's the key idea. And you do that for user, for the owning group, and for everyone else. Yeah. So 3 times. So basically, it boils then down to actually specifying your permissions in that way. Cool. Cool. The commands that correspond to that one, we obviously need to be able to set an owner of a file or a directory and set the permission set itself. So the way of setting actually an owner is to use the chown command. Chown. So chown user A file name. So the user A afterwards owns that is the owner of the file name. If you want to do that for folders, you need to use the parameter -R, and capital R stands for recursive, right? For this and all subfolders. Okay? Everything under this particular branch. If you want to change both the user and the group, you need to separate it by colon. Yeah. So user :group, meaning if you want to change the owning user and group, I'll try to show that briefly here. That's probably a good one. Which ones can we user 2 user 2. So I want to change, or let's only change the owner for now. Test file. So you have to say yeah. So what I did here was basically running chown on the top line, chown user 2 test file, and you notice I need to use sudo to do that. And if you look at the output afterwards for test file, you find that the owning user now is user 2, right? So it's one way of changing the owning user. If I just want to change the owning group, for example, to user 2 group, I can just say :user. If I want to change both at the same time, I would write it this way: user and group. But for now, I just want to change the owning group. So you find that test file is now completely owned by user 2 as opposed to user 1. Yeah. So chown is the command to do this, and you can either selectively change the owning user or the owning group or both of it. Right. Cool. And the way of actually modifying the permission set is to use chmod. So chown for the owner, chmod for the permission set. For example, if we use the test file again, what's the permission set in octal representation for test file right now? How would you represent it? What's the octal representation? Right. Just the representation first. We'll come back to it in a second. Test file. So it says RW, RW, RW. So what would that be? 666, right? Yeah. So read, write, read, write, read, write, right? 4 plus 2, 4 plus 2, 4 plus 2, 4 plus 2, right? Cool. Can you wait? Just think quick. So If we, for example, want to give the owning group only read permissions, what would be a good permission set? So no one. So if only the owner should be able to read and write, the group should only be able to read, and no one else should be able to do anything. What would be the octal permission set? Yes, 640. Yes, 640. Right, 640. 6 read and write. 4 read only, and 0 nothing. Right. So that's the way to go. Cool. We do that for test file and see if it actually works out, or if I'm telling rubbish, which is not. So test file down here. So again, it's still owned by user 1 and 2 because chmod doesn't affect it, but you notice that the permission set has changed. It's R, W, and R for the owning group right now, right? So that's the way of how to dealing with permissions. So now your question.
How will we be using groups in this course in Ubuntu or in Linux? How will we be using them in global modules?
Right. So one possible way is to have shared directories, because you can't. You notice here that the user is always a specific owning user, right? But imagine you have a shared file via which or to which multiple user accounts need to have access. For example, service user and your local user. Then you can use the group to exactly do that, right? So you can have a directory, make the group owner of that directory, associate users with that group, and therefore they will have write or read access or whatever you specify on that particular directory. Does that make sense?
So why will we be using several users on our groups?
Well, because you will need to deal with, well, first of all, it's obviously for testing purpose. You may have different permission sets you need to be dealing with. For example, you may want to check whether you can actually start your application without sudo permissions. So you want to have a user that is constrained or not to. You need to interact with service users as well. So it's an inherent service, multi-user environment. So not knowing about multiple users or managing them in Linux is a bit scary. Even you kind of need to manage your own user as well in a way. Yeah. But I think the permission set is very generic. Plus, if you know that one, you can deal with any Unix system. Yeah, super generic concept that won't change in the foreseeable future anyway. Cool. I think. Here, basically, an overview of the different permissions, how they work on files and on directories. For example, if you have the X permission, the execute permission on directories, it means you can enter directories. Yeah, just to clarify what those kind of mean. If you have W permission on a directory, you can add, delete, and rename files in the directory. Yeah, and R is the ability simply to list the directory. But listing a directory and entering is two different things. Yes. You can list the contents of a directory, but you're not able to enter the directory and do any operation there. So it's a very, very confusing concept. That's why it's quite important to know what RWX do on directories and what they do on files. Files is the obvious things, right? Reading files, writing files, or changing files. X is executing, meaning running files. Yeah. If you have a bash script and you don't have the run permission, you can maybe be able to write to it or read it, but not being able to execute it. Cool. Any final guesses? Does anyone want to guess just to train your chmod? So what's the first permission set? What's the user, what's the groups, and what's the other permission? Just write, execute, right? Yep, it's correct. Anyone else? No? Cool. So 212, what's this one here? 421? Cool. 777, well, everything, right? So you can do everything on that particular folder. 644. Yep. Yep, for the group and all the others. Cool. 511. Cool. So execute and read, and the others can only execute, right? The group and others can execute. Last one. Yep. Yes. So that's a bit counterintuitive. giving everyone else full permissions, only the owning user has less permissions, right? So doesn't necessarily mean it makes sense, and be mindful, you can easily lock yourself out as well if you don't think carefully about the permissions of the owner, right? So you can actually lock the owner out if you want. Cool. I will leave it at this, so you have suffered enough. The slide set is online. Obviously, I'm available for help. I'll stick around a bit longer, help you guys. For everyone that uses the stick, there are some instructions of how to create a new administrative user. In fact, the idea is to port your cloud-related stuff to an explicit user account. Yesterday, to an explicit user account to ensure that it's not overwritten if you're modifying the if you're playing with user accounts in the system. So if you're a live USB user, do that first. You create a new user account. You can use that instruction I added in the beginning, and you copy all settings from your current account, which is Ubuntu most likely, to that new user account. Those are the commands. You should be able to understand them now. So sudo copy everything from Ubuntu to that new username. So I just call it cloud here. It could be anything else. You just need to remember it, and then make the cloud owner, the cloud user owner of the whole directory as well, of all the contents. Yeah. So a permission set is unchanged. Only the owner changes, and afterwards you should be able to run everything what you did before in your new cloud user. Like go check for go path and check that Heroku still works with gcloud as well. I'm happy to help with this one. If you have questions, first of all, I'll stay here for a few more minutes. There are some more tasks attached that I would like to run through if you, just to get your head around the whole user idea. You know, to get comfortable creating users, permissions, and so on. So we don't have those questions bubbling up in week 10 when, oh, how do I set permissions and so on. You should be fairly comfortable by then, because obviously that's why we're doing it here. So it's like 3 slides of some tasks you can do that basically continue what we talked about here. Cool. Any other questions right now? Blackboard is, by the way, is a good discussion forum. Just post questions there that may or may not come up over time. You can also post anonymous in case you're not, willing to share your identity. So we'll respond to it as soon as possible. But if you have questions now, please, I'm available. So. Cool. Cool. If not, well, you're free to go. I mean.
I have a question about this installing a cloud. I made it run locally, and now I was wondering to put it on the deployment. And this is the command to put it on the cloud. But should I stop this running locally and then start again in the same folder this deployment command, or should I run it in the separate terminal?
Det ringte og ville ha 10 000.
Jeg har minnepenn på Gjøvik. Jeg kan gå og pugge det hvilke sensorer som skjer. Kommer inn på administratorkontoret for å gjøre fra power-off til ja, men det er det de ikke gjør. Så pugger de og når du tar ut oss, så kjører du sånn biler. Så det bare sånn, passer det seg administratoren ikke ligger der. Den minnepennen, det er sånn så Nei, jeg har ikke den. Jeg synes det kunne være greit å være med på en flere fag, men når jeg bruker 2,5 timer til hjemmesmaken, og ja, dessverre prøver å vurdere om hva jeg skulle ha fordi mer bruker jeg på den og her kan jeg finne selvfølgelig selv da jeg synes det er greit å selvfølgelig viktig den som vi kommer med